Okay, hi everyone, and welcome to my talk about blueprints, blending system architecture and creativity. I'm Michelle Chapman. I currently work at Deep Silver Dambuster Studios in Nottingham. I'm the lead technical designer. I've previously worked at places Cavalier, Lionhead, EA. I've been working on Unreal Engine for about 15 years, all the way back in UE3. Today I'm going to go over our approach to the studio for how we make our unannounced game. So sorry for the no project specifics in it, but yeah, how we make it as a studio, what standards we use, how we build our blueprints, and how that enables our design departments to create the game that we're trying to make. So first off, Unreal Engine 4. Always many options. So you can make a game using only code and no blueprint at all, which is one of the options that you could do. It puts a high demand on your engineering team. Rapid prototyping could be a little easier because you get bogged down in all the system architecture and changes can be a bit more difficult, but it's much better for performance and it's much easier to debug in Visual Studio. You could go all blueprint, no code at all. It's more accessible to the wider team. You can prototype very rapidly on features, but it has a greater performance cost. It's less optimized, can be more difficult to debug because you always end up falling back to print strings and debug no matter how much debugging functionality goes into the engine. It's always a bit trickier to find. Or you can do a blended approach, which uses a bit of both. So best of both worlds, but also has its own negatives. That's what we're currently doing at Dambusters. So we use both code and blueprint together in a nice way. It takes the burden off the engineering team because more people can help. You can prototype quickly, design can iterate and play around for a little bit to find out what they want. And we can make sure that data is exposed in a nice way to everybody. Of course, coming with wider blueprint usage for the rest of the team and easier access, it can cause performance issues if you're not careful with them. It can be more difficult to find bugs. Is it in the blueprint? Is it in the code? Is it in the animation graph? Who's responsible for it? And where does all of the data go? There's always a lot of data. So if you're doing blended, you might end up with some team structure questions like when do you use code? When do you use blueprint? Who's responsible for deciding on the switch? How do you maintain the systems with blueprints when anyone can edit them? What do you expose to other departments? What do you hide away? Hopefully I'll answer some of these questions during the course of the slides. Should answer all of them. So at Dambusters, what we did to try and utilize the best approach in Unreal is we created a technical design team. We are part of the engineering team and work closely with code, but we also sit on the design side. So we have a good understanding of the design principles and act as a bit of a bridge between the departments to try and help communication. Sometimes designers speak one language, programmers don't understand, everybody gets confused. Helpfully with us in the middle, it should smooth it out a little bit so that everyone can get the best of what they want. We are mainly responsible for the blueprints in the studio, but it doesn't mean it's only us that are allowed to touch them or change them or create them. It's not. Any department can do it for what they want. We create tools for other departments as well as things for in the blueprint, so it's not just things that go in the game. And yeah, it's up to us and code when we move something to code or when we move it from code to blueprint. It's a two-way street. We all get a say. It's not imposed on anyone. It's all very collaborative. And hopefully all the data's in a nice exposed way for design so that they don't have to think about the technical side too much. They can just open up a data asset or an instance variable and tweak away to the heart's content, and they get to spend more time actually making the game feel really good instead of bogged down in the technical aspects. It's a brief little overview of our cycle with going through a feature. So we go from a feature request into a technical specification where we break down what we think we need, if any other systems we've already got can be reused, if we need a new one. And from there, we might just go straight to code because it might be simple, straightforward, better off in code. Otherwise, it might go to a blueprint prototype if design aren't sure what they want so that we can iterate and work out. And from there, we can put it in blueprint or put it in code, and we have a review at every stage to see if we should send it one way or the other. It's working well for us at the minute, so I think we're on the right track. Now, obviously, coding standards. This is the boring bit. It'll probably go on for a while. Coding standards, well used, well understood. Blueprints often suffer from it, seeing as they're so accessible to everyone. People can run riot with it. You should use some standards in them. It will help your team after them. And the next couple of slides will go through what we use at our studio to try and make it all clear. Now, I wrote my first standard way back in UE3. The very first time I opened it, we got given some sample content from a level of a very well-known war game where you collect lots of cogs in it. And I had a little look at the level blueprint for it, I couldn't find the exact picture, so this is just one off of the internet from the documents, but this is what Kismet used to look like in Unreal 3. Imagine that 50 times over in a level script version, and your brain will probably do what mine did, which is it just looked like spaghetti. It was unreadable to me. So tidy blueprints. As soon as I saw that level, you should make your blueprints tidy, because I don't know how they managed to make that game with as few bugs as they did with how it looked. It's truly incredible. So keep your blueprints tidy. It will help you in the long run. Some good tips for tidy ones. Functions are good. Don't leave everything at the top level. It will just become unreadable. Wrap your logic in functions where they make sense. Use comment boxes. Reroute nodes are your friends. They will make it so much more readable. And there's a couple of other functions which will help you with them. And this is an example of one of our UI blueprints. It's for the HUD. It's not too bad, that one at the top level, but you can see it's a bit messy. You can't really see where anything is. You don't know what any of them are doing. Use functions and apply comments. You get a nice pretty picture like that. You can instantly see where the menu options are, where the inputs are, and where the initialization of everything is. Straight away, just more clear, so easy for anyone to go in and fix a bug if you're not there for any department. Reroute nodes. Yeah, that's a bit of a mess. As you can see, green lines everywhere. It gets very hard to see things. Simple reroute nodes, nice and pretty. Function inputs, a new feature that went into Unreal recently, I think a couple of iterations ago. You used to have reroute nodes on your function names when you input so that you could use them across the graph. You can just get them like normal variables now, so you don't even need your reroute nodes. I really like that one, it's very good. And of course, I am a bit pedantic when it comes to straight lines in blueprints. I really like them to be straight, so you can align it on the right-click menu, and you don't have to spend ages moving it up and down like you did in Unreal 3 to make it nice and straight. Bing. Very nice, I really like it. Get sadly excited about nice straight lines. So yeah, if you follow the standards, it will give you some benefits. You will get a reduction in bugs just because you can see it and read it easier. So you'll automatically just write them a bit better because it's just more readable. You can distribute your maintenance across multiple departments. It won't all be on your technical design department or your code department or your design department. Anyone can just jump in and fix it because it should be clear and readable. And also another big win for us has been seeing what systems have in common. If you have them nice and separated in their logic, you'll be able to see that actually those 5 blueprints all share this same functionality. So maybe you should centralize it somewhere else instead of having 5 different copies everywhere. It's very helpful. We do have some style standards as well. Same as code, we use Pascal case for variable names, just because code do and it makes sense. Also makes them easier to read. I like all of our exposed variables to be in their own sensibly named categories instead of just all being in the default category and clogging it all up. And I like tooltips to be on them, just for some extra explanation. And of course, comments, I've said that one a lot. I mean, you don't really have to follow these, but they do make it nice and contained and just easier to use. And you know, if you're in categories, your designers can find what they can tweak easier. And it all just makes sense. So these ones are just common ones. I'm going to go a bit controversial here. Feel free to disagree with me, I'm sure a lot of you will. We don't use tick in our studio on your blueprints. It takes quite a lot of performance to have loads of ticking blueprints, and normally there is no need for them. You should barely have any ticking blueprints at all, because they just don't need to. Instead of using tick, use callback events. You know, get told when something changes in there instead of ticking on it. There will be some rare exceptions to this. Our own project, our music blueprint for the music manager does tick, because I can't stop it and it upsets me every day. But there will be exceptions. But yeah, you don't need it. It'll save some performance costs. Just turn them all off by default and you'll be better off, because you opt in when you want it. Delay nodes. Yeah, don't use them. You could cause yourself no end of pain trying to find out why something isn't working because someone's chucked a sneaky 0.5 second delay node in there just to cover up a timing issue. Investigate them a bit more first before you just throw one in, because ultimately you'll find a deep-rooted system in there. And a lot of the time, if you do need a delay node in your blueprint, use a timer. Timers can be stopped and cancelled if your game state changes. So if you've got a blueprint sat there waiting for 5 seconds before it should do something, but you have a condition that means it shouldn't do it, if this happens, delay node, you can't stop it. Your blueprint will carry on executing as soon as that 5 seconds are up. Timer, you can cancel it and it won't. It will save you loads of time tracing down random bugs that are really hard to repro. So try to avoid them. Now the biggest one, no level script. Outside of testing, prototyping, local levels only, we don't use it in our studio. course, as you all know, level script's unique to that level that it's in. You just end up with the same things copy and pasted in 50 different locations. As soon as you find a bug, you've now got to fix it in 50 places instead of one. There's not really much core for it if you architect your systems in the right way, because your design teams can still link things together like they would in level script, just in a more reusable way that doesn't mean that it's unique to every single level. It's more common. So, standards. If you want to keep your standards, you've got to review things. Otherwise, people won't adhere to them, and it will all just go entirely wrong. Now, there was a big resistance when we first brought in blueprint reviews, because people thought that we were restricting them and that they couldn't do any work and that we were trying to stifle the creativity. It's entirely not what it is. It's just to maintain the standards, make sure that sensible things are in blueprint, flag up any things that you can instantly see that should be in code because it's way too complicated in blueprint or it's going to be a big performance cost. That's just what it's there for. If you embrace it, your blueprints will be better, your teams will be better, everyone will work better, and it will just be good. Large changes, we still do at-desk reviews using the diff tool because it's easier to see all the different changes and you can go through it. And sometimes that does involve you having to then redo the changes after because someone suggested a more appropriate system to use that you didn't know about. Small changes, we use CodeCollab. We just upload a screenshot of the little changes, a new is valid node added in there to fix a crash, or I've just ticked that box for that variable for this blueprint or tweak that number. Just upload a screenshot and it can be done just as quick as if you didn't do one at all. And detailed change list descriptions, always very useful. We also have some asset validation at our studio, which will prevent you from checking in if you're doing something that you shouldn't do. So again, people didn't like this when it first came in, but they love it now because it's helpful. You're not going to break anything when you check it in. Our validation tool will flag up if you've named something wrong. So we have a list of valid prefixes that you're allowed to have or proper naming conventions. It will flag it up before you can check them in, so you won't end up with 6 billion different named assets because it's all correct to start with. We run checks to see if you've got a data-only blueprint that's got data blueprint logic in it, so you can't sneakily check things in without telling anyone because it'll flag it up. We also check to see if you're referencing items, objects, assets that aren't actually in the cooked folders, so like your developer folder. There's been many a game that I've worked on in previous companies where we've ended up including the developers folder in the cook because there's so much content in there that it was too difficult to get out. So we've got validation on that so that you can't do it. I mean, you don't have to validate your own developer folder. That's fine. You can work in there as much as you want, but as soon as you're trying to put it in the main game, everything's got to be in the main game. We use collections at our studio as well. We've got certain rules on production levels against test levels that say that all assets have to be in a collection, just so that we can keep a big watch on where everything is. If it's not in a collection and you're using it in a production level, you can't check it in because it will stop you. And it also has a little option on there that asks you if you've cooked before you check in. So you have to physically lie to everyone and tick the yes, I've cooked button, even if you haven't, because so everyone knows it's really important to cook before you check in, otherwise it might break and you'll end up with lots and lots of cook warnings, and then it will take someone like me a couple of days to sit there grumpily going through and fixing them all. So just make sure you've run it, little box. It's always helpful and it solves problems. Our validation tool also runs in editor, so while you are happily editing away your levels, you might occasionally get some pop-ups telling you that you can't use that asset, it's not in a collection, or that this is wrong. We're still working on improvements to that to make it a bit more easier and proactive. Anything that catches problems earlier on in the development cycle is always positive, but it is a hard sell to the team when they first start trying to use it. So that's pretty much my standards and my iron fist of how things have to be maintained in it. But how do our design teams use everything that we make for them? Well, beautiful thing about blueprints. You place it in level, logic's shared, but you can have per instance values that people can tweak and change. Designers like them because you can make different scenarios by using things and they don't have to worry about the logic. They just plug and play. It's very nice. So, plonk your level in, set your thing up, and off it goes. It should just work. And we provide certain in-editor visualizations on the blueprints themselves when they're selected for you to see various things. The little white lines you can see here is an airflow for things to get sucked into fans. And that shows you which way it's traveling and the intensity and strength of them, so you can see it visually without having to play the game, which is nice. So let's go through a little scenario example. So I've got a player. They walk into a room. Door locks behind them, barrel explodes, some particles happen, an enemy spawns. You might be thinking, that's real simple in level script, but how do I make it now that you're not letting you use it? Well, That's where some of our blueprints come into it. This simple scenario can be broken down into an objective blueprint, which will be player get into the room. You just get to a location. It's an objective. A door blueprint, obviously all the doors blueprints, so you don't have 60,000 different variations of doors. One blueprint, just select your mesh. An environmental hazard, that's the barrel blueprint. Explode if someone shoots it. Particle effects, obviously, and then an enemy spawn blueprint. It's also a blueprint instead of hand-placed spawners. Now you can tie all these together in Engine, in the editor, with links through the levels in a little system that we've made, utility blueprints. They are essentially just blueprint interfaces, but they have a little array. So you can plug your soft reference to your actor in there. It's got a little delay time, so you can make it wait for a certain amount of time before it sends the message. And you don't need level script, which is great. I love it. You get the point. I don't like level script, but it's fine. But yeah, make it nice and easy for the designers. The interface message, we do have a separate enum that controls it, which has got the same names as the functions in the interface, so that they can select it from a nice little drop-down list. Many days have I spent chasing spelling mistakes and errors just because you typed one word wrong in a function name. So nice little little more maintenance on our side, because it's two things we have to keep up to date rather than one, but I think it's worth it in the long run. These, we've got various different ones in our current game. The picture you can see up there is of our general interface that practically everything implements, but we've got some specialized ones for doors that will have functions called lock and unlock and jam and things like that. And we have different ones for particle effects, audio, explosions, damage all objects. Just makes it nice. Obviously plug multiple actors in, your time delays on, and you're all happy. So responding to the blueprint interface, basically all of our objectives will implement the relevant blueprint interface to them, and they decide how to react to it. It's not the object that sends the message that tells it how to react. It's the object that receives it that does it. This means you can keep your logic inside your blueprint, your other systems, that the objective to enter the room. It doesn't need to know how to tell the door to lock. It only needs to tell it to lock, and then the door will handle it. It just takes a lot of the complication away, and you don't fully need to know how everything's going to react to hook it up. You can just put an interface event in there and see what happens. It takes a bit of the burden off of your design teams having to know the fundamentals and the insides and out of everything. So the object itself will just respond to it. Like this one, when it gets our general message for triggered, it turns on an interaction and it changes its display text. Now that's all great, but you can't really see how any of these things link together in the levels now, because you've just got blueprints all over the place with no idea how to link together. So we made a little bit of visualization. This does need some improvements and work, but it is incredibly helpful. So we call them blueprint links. It's a separate plugin. It works only in the editor, so it doesn't get cooked out. It's not in the final game, but it allows you to display the links between the different blueprints that you've got. And you can change the colors of the arrows based on whatever you like. So, if I was pointing at an objective actor, I could make it yellow if I wanted, or it could be green if it was pointing to just another actor in the level. In our company, we only use two colors. Quite a large amount of our level design team are colorblind and can only really distinguish between red and blue. So we only use red and blue to help them. We use red lines to show the forward path of it. So the object that triggers the message will point to the ones that are receiving it in a red line. And you don't know if you can see it on this screen, but there are little arrows that show the direction of travel on there. And the blue arrows, the same, I did it the wrong way around, didn't I? The blue arrows show you the link forward. The red ones show you the backward link. So no matter what you click on, you can see where it's being triggered from and who it's triggering, which is all very nice. But it also works with multi-select, so you can select multiple actors in the level and see the overview of how it is. I think it needs a little bit of work because it can get a little bit messy, but at least you can follow the flow through in Editor to see where your problems are going. I'll go over a little bit of how we make some of our blueprints now. It's a bit confusing saying, yeah, use all these things we've made you to make a game. I haven't told you what any of them are, so it's a bit confusing. Most games have missions and quest systems. In our studio, we call them objectives. They're little self-contained chunks of blueprint that contain their own logic that do things. Like the example of that scenario, reaching the room. That is called a reach objective in our game. As soon as a player enters the area that you specified, which can be any shape, it can be a sphere, it can be a box, it can be a rectangle, or it can be a nice hand-drawn in the editor star shape. You can make whatever shape you want for them. As soon as it reaches it, it'll trigger its own logic. Now, obviously, it's made up of a code-based class, obviously, so that we can debug things and everything like that. You have reusable components that you can plug onto it for how it displays UI to the player, interactable components that's used everywhere in our game. And it contains its unique logic for what it does, which in this case would be a trigger area volume, and the fact that we're listening for players. Could quite easily change it on a per instance to make it listen for whatever enemy types you've got in your games and things, but by default we give you the player because that's what we want to use most of the time. Now all of the objectives have the ability to activate those little blueprint utility functions, actors that I was talking about earlier. So you can listen to objectives starting or finishing and automatically trigger one of those off that can be linking to 4 other actors in your world. It's how you make the nice flow. This is a little picture of one of our simplest objectives. This is basically just talking to an NPC in the game. So you just walk up to them and it'll trigger a little UI pop-up on there telling you to press a button. You talk to them. You press it, it'll zoom your camera in onto the NPC, they'll play all the dialogue lines that have been set up in there, whatever animations you want them to play, and then it'll pan out at the end and release you back to the game content. It's one of our simplest ones that we've got. But, you know, the comment boxes obviously makes it really easy to see where all the information is. You can see the skipping support, you can see where the initializations are, where the actual logic are. You can see in the top box the components that it's made up of. So this one's got an interactive component, a quest delivery component, which is the bit that controls the dialogue and animations, and objective icon, that's our UI. And you see all the variables with the tooltips and categories that they're exposed in. Now, linking all these objectives together, we've made a mission system. Again, this is on a plugin, so it can be game agnostic. It's got in-editor visualization, so you don't have to go into a different application to edit this. You can do it right inside the editor. It just opens a different editor mode, and you can plonk down nodes for each objective that you link them to, and what happens when it succeeds or fails. You can even do logic in here. We have logic nodes where you have to have all of the input pins fire before it will go on to the next one, or you can do an OR. We have lots of different systems in there and cutscenes, and it's nice, very easy way for you to see it. Beauty of a system like this is you can also debug jump to any point in any mission and any objective in the game, and it will set it up like you've played the game. It's a real good time save. It's very nice. So Sandbox. I think I'm going a bit quickly, but I'm running out of time. Yeah, every game has Sandbox. Things that blow up, things that you pick up off the floor. Ours is no different. They're constructed very similarly to how our objectives are constructed. Apart from they rely a lot more on data assets for the designers to balance them rather than per instance values. As you can imagine, per instance, you can make those different for every single level that you go in. Something like environmental hazards, say that barrel and how much damage it does, which particle effect it plays. You wouldn't want that to be different on a per instance thing like you would for objectives, because they're much more unique. You'd want it to be the same way across the game. So we fix that problem by not using the per instance. We'll have a data asset that's set, and that's set in the blueprint so that you can't change it, but our game design teams just open that asset up to tweak it, and they can rest assured that it'll be the same across the entire game. We're not going to get a bug that says this specific barrel in this level in that right-hand corner does 4 times the damage to everything else. You're not going to get that because it's all on the data asset instead of the per instance. That's the main difference between them. And I could talk about every one of these slides for about an hour in their own right, so I'll just try and rush on past, but feel free to come and argue with me after. Narrative. It is a big part in our game. Obviously, you have lots of different narratives. It's from the cinematics to talking to NPCs to the NPCs just speaking when you go near them or doing their own thing during the daytime cycle. We also can't enemy spawns under activities. You don't want all your bad guys just standing around waiting for you. They need to do things as well, else your game would be a bit boring and easy. And also for player triggering different events. They're all very complicated. They're all very different. They're all under the part of narrative. They're all blueprints with different things that you can do. The little picture one that you can see there is the same as the example I showed you earlier for talking to an NPC. It's got lots of different settings, which our animation department all say are extremely important, but I'm not quite sure why I need to override everything on an instance basis, but it's what they want. It will automatically go to the library of animations that they've got and just pick a random talk animation, but the options are there if you want to tell it to play a specific animation. Specific text that you want it for the subtitles, the audio you want it to play, how long you want it to pause at the end of the line. This is part of the prototype system because we haven't got the dialogue in or our localization stuff in yet, so you can type it in here to now to see how it works and how it feels. But as soon as our dialogue system comes in, we'll be able to transfer it all across without much work, because you won't have to change it in the level, because it's a data asset. So you can just update them without having contention of this, your level designer's got all the level files checked out because they're redesigning the mission. It doesn't matter to the narrative design. They can still change the text without waiting for it. It's all very nice. It took a long time to get to it. Lots of arguments, but Big topic, cinematics. Always very problematic. Our cinematics, we're making a first-person game, even though it is multiplayer. It just has its own problems, but that means that there's a lot of common functionality in the cinematic blueprints, like binding the players. When the original binding on the level sequence came out in Unreal, the tutorial shows you how to do it in level script. It's not entirely helpful if you're going to have 6 different, let's see, 30 different cutscenes over 12 levels. That's not so handy, having to do the same bit of level script all the time. So we made it a blueprint, but we also made it an objective blueprint so that you can directly jump to the objectives to watch the cutscene from the front end and have the mission set up as if you played all the way through it. It makes it very handy for debugging. And now animation from the front end menu just goes straight to the cutscene that they've just worked on, check how it plays in game. It's as simple as just pressing on the name of the cutscene. So they don't have to play through and try and find everywhere. Because, level designer are always moving where things were, and you can never find it when you haven't looked at it for 2 weeks. You don't have to with this, it'll take you to it, which is very, very nice. Our NPCs are blueprints as well in the world, and the objective will make it that it automatically binds them to your cinematic location, so you can guarantee that they will be in the correct place to play the cutscene, no matter where they were wandering off to when you were just in normal gameplay wandering around. They'll be in the right place, so your cinematic will look right every single time. Now, moving cutscenes, it's always a challenge, always breaks, nothing ever works. Animation have to redo everything a lot. The floor suddenly changes, animation have to redo it. You want to push it 2 centimeters over there, it can take days. So we made a little actor, we call it cinematic root actor. Does absolutely nothing. It's got nothing in it, it's blank, absolutely nothing in it. It just has a scene root in it. But we use it as the anchor point of all of our cutscenes and cinematics. And everything, all your skeletal meshes, all of your props, they all go under it in the hierarchy. Makes moving them easy, because all you do is you select your cinematic route and you can move it, and everything moves, but stays relative to each other as it should do. Makes it much, much easier to move your cinematics. It makes animation happy, because you don't get that character suddenly being 2,000 centimeters away from where your other ones were, because you forgot to click that one and move it. So it does make it a bit easier, but yeah, it's just one blueprint with absolutely nothing in, which sounds very strange. We use it as the anchor point. All the characters are animated from that as the origin. So it doesn't matter where you move it to in the world, they'll still work and line up. If you've got 2 characters that come and do a handshake, it will still work even if I've moved it, because they're animated from that anchor point, not the world location. It's very good. Yeah, that's about it. I think I've rushed through it quite quickly there, haven't I? But yeah. So yeah, that was our approach. Why I like blueprint standards, why you should do reviews, how we make our blueprints, how we make our quests. Brush through it very quickly, but sorry. We're hiring, please visit our website. There's some blog posts on there as well, it's not just boring things. Yeah, that's it.